think of before? Okay. So remember, the same things apply every time with sinusoidal, right? You want your x scale, your y scale. The y scale is tricky, and then the question is going to tell you, do you start on the max, the mid, or the min? Like, it will give you a starting point. We used to use our calculator to find that, right? But it's the question has to give you that, right? So page 36 here, the height of the water in a bay varies sinusoidally over time. On a certain day off the coast of Maine, a high tide, that's important, right? A high tide of 10 feet occurred at 5 a.m., okay? And then it says that a low tide of 2 feet occurred at 1 p.m. Write a model for the height in feet of the water as a function of time in hours since midnight. Okay. So we're going to come up with that equation. The AC that I'm going to give you will ask you to graph it right away. Don't graph it right away. First go through these steps, come up with your equation, then graph it, okay? So here we go. Let's come up with our x scale. Before we come up with the x scale, we need to find the period, right? So let's see what happens here. At 5 a.m., we have that high tide, and then the tide obviously will lower. And then at 1 p.m., we're at the low tide, right? You should notice that they're giving you half of the period, right? That you're able to find out half of it, and then we'll just find the total in a bit. But we know that at 5 a.m., we're at 10 feet. And at 1 p.m., we're at 2 feet. But you don't want to write 1 p.m., you want to write down 13, right? Because it's since midnight. So this would be 13.2. Right? So that's what is given to us. And so we're just going to kind of complete that cycle, right, using symmetry. So you do it as you see fit. I'm going to go 2 times 13 minus 5, because it's the x values that determine the period, right? So that'll be 2 times 13 minus 5, which is 8. And so our period is 16. And we are in hours, right? The x variables in this case is the time. So perfect, we've got that. X scale can be found like this. Okay. So you got that figured out. Perfect. Now we need to figure out the max, mid, min. Not too bad in this case, right? Y max, mid, Y min. The max is 10. So in this case, right, every question will vary how you figure this out. Every question will have a bit of a nuance here. Do you only get the low point and the amplitude, for example? Then you just jump using the amplitude, right? In this case, they give you the max and the min. So I will just go ahead and say, hey, I can find the mid by just adding these two up and dividing it by 2. Right? So that's 12 divided by 2, which is 6. So that's actually all in feet, right? So 10, 6, 2. Now let's check. Is there consistency? Yeah, there's 4 difference, and there's a 4 difference between the mid and the max. So we're doing things the way they're supposed to. Okay. We're doing all right. So again, this is my Y scale. This is the work I did to figure out the X scale. And you need a starting point, which they give us, right? They give us, you can actually choose to start with this, right? In this case, but I will start with that one right there. Because you want one that is either in the max, either min, or at the mid. If you ever come across a question where they give you the mid, they have to give you some kind of indication whether you're going down or you're going up afterwards. Okay, so watch out for that. They can't just say mid and leave it like that. Okay. So here we go. I'm going to come up with my points. This is how I do a modeling situation. I start at the max in this case. I'll come back to it. Halfway, I'm at the lowest point, and then the other two just come in like that. In this case, I start at the high. Could have started at the low. It depends on the context. So this is 5, 10. This would be 9. Sorry, let's put that down here. 10, 6, 4, so we don't get things mixed up here. So this would be 9, 6. This would be plus 4, right? Yeah, 13, 4. This would be 17, 6. And 21, 21, 10. Okay, so we've got my 5 points, which is a requirement to come up with the equation. Yeah. Ah, yeah. Good thing I have students that pay attention. I could sense it. Some of you were like, what? What's going on there? In my books, that would be a half mark deduction because I see you doing that, right? Like if you have 2 feet here and all of a sudden 4, transfer error, not a big deal, right? But try to avoid it because I want to just go check, 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 check on my test, right? All right, so here we go. Stat, calc, synreg, and let's go ahead and come up with the equation. This is my radian calculator. I always mix them up. And then we're gonna now we can answer other questions. What I would say about this mistake that I just made, at some point along the line, right, as you're working through it, that should kind of come up, right? If you always question your answers, you should have been like, wait a minute, like what's happening here? Because the amplitude, which we didn't find out here, we didn't find the amplitude, but it is 4, right? And some, like if you come up with your equation and your amplitude isn't 4, right? Right, it should raise a flag, right? And that's just always kind of test your answer. Does it make sense? Right? So 4 sine of 0.3927x minus 0.39 plus 6, right? And there we have it. Maybe down the road I should make that a step, figure out your amplitude as well, just to as a checkpoint. So there we go, that's A. So that's the trickiest part, coming up with all the pieces you need to figure out your points. Later today, I'm going to come up with one where the finding period will have a little bit of a hook on it yet. You're going to have to make sure you only find one cycle, not, they might say 10 cycles, 20 cycles, 5 cycles. That's how long it takes. You just want one cycle. Okay. Okay, B. What's the height of the water at 3 p.m.? Y2 is 15, right? Second, trace 5. So let's see how this graphs. So I always go to my window right away. You could do zoom 9. That's up to you. I know that one cycle is 16, so I'm going to go 32. Y min is 0 would be fine. Y max I will go 11. And there's my wave. And no, I'm mixing it up. Sorry, guys. Is it Friday? Second trace 1, x is equal to 15. That's better. That's more like it. Uh, 3.17. 3.17 feet. That's all I need. Just make sure units are there. How long does it stay at or above 8 feet within one cycle? That's where you need to use this, right? Second trace 5. So one cycle goes from here to here. Okay? Now, we know that you should recognize that from, like, we're interested in this stretch here and in this stretch right there. Right? So you got to be careful here. If you subtract these two, you're going to find the time that it's spent below. Right? When you subtract, you always find the cap, right? Or that little, right? So you need to watch out. So we're gonna find the difference and then take that away from a period to figure out the time spent above. Okay. Is there another way to do this? Finding the difference between these two, it should give you the same. Okay, so let's figure this out though. Let's do it the long way. So that's 7.x1, let's call it 7.6667. Second trace 5, jump to the red line. That is 18.33. There you go. Delta time of below, right? Time below. And when you do this, I'm assuming you're using all 4 decimals. Okay. Nope. 7.6667. That's 10 hours. That's time below. Okay. Time above would be period minus time below. So that's 16 minus 10 point. That's 5.33 hours. That's what I'm after there. I'm going to give you a little diagram here. This is our graph like this. This is the y8, right? So this is x1, this is x2, okay? When you subtract them, right, you're always finding that little cap, the time spent there. We want the time, in this case, above. So we are actually finding those 2 stretches by doing it this way. I just checked. If you would have just focused on the cap here, like from here to here, you get the same answer. You get 5.33 as well. So, and the reason being is that when we do the find the time below and subtract that from the period, you find this little wave here and this wave there, right? If you were to combine these two, you actually get that cap, right? If you could cut it and actually lay it over. So you decide how you want to do it. Whatever makes sense to you when you read that problem, you just go for it, okay? D, what's the domain and range? Actually here, what is the domain in this case? 0, in this case, it's actually 0 to infinity. Oh, what? There's infinity, Mr. Dirks? I thought we were done with infinities. Well, this repeats, right? A tide cycle is actually ongoing, right? It can actually keep going. The same thing will just repeat itself, right? 24-hour cycle. In this case, it's a 16-hour cycle, but it continues, yes. So that's okay here. Just keeps going, right? Because domain is time, right? This is time. Starts at midnight. We can't have negatives, right? We can't have negative time, but we certainly can keep going once we start. And the range is just the lowest to the highest. Right? This is the height in feet. I would read the question. Like if I give you some indication that this ends, right? Like if there's not specified, if it's time, then just keep going. Especially hours of sunlight, depending on the day of the year. Like that continues every year, right? December 21st is the shortest day every year. Did you know that? It's the shortest day, and then you actually increase again, and it goes up, and you get more and more and more until you get to June 21st, right? That's the longest day, and then days get shorter afterwards. So it's a cyclical. It's the same thing, right? So in this case, we can actually just keep it. All right. That's all I'm going to say to this one. This is actually an old AC. That's why there are marks attached to these questions. So the equation actually got you 3 marks there because this, right? You need to do so much in this case to come up with it. It varies between 2 and 3. It depends on how much needs to be done to get it, right? In this case, this step right here was a little bit of an added, right? You have to like figure out, oh, I'm getting half of the period. I need to figure out the full, right? Stuff like that. We'll do more, but now it's your time to shine. Paddle wheel boom operates on the Red River. That is propelled by a large wheel. The diameter, height diameter is 6. This is maybe a little, like I give you more information than what you needed, but anyways, there's 4 feet above, 2 feet below the water, and we assume that, right, the water level is h equal to 0. That's also more information than what you technically needed, right? We did something similar like this yesterday. It takes 5 seconds for 1 complete revolution, right? And we're assuming that p is the starting point, so that's, in this case, we start at the max, right? So we have everything we need. Maybe some labeling here. Here, height would be 0. My min, because I'm going below, right, it would be -2 here, -2 feet. The max would be, it says 4 feet above, right? So we know that this is 4 here. Regardless of how you do it, you can go from here straight to the top, knowing, right, that the diameter of this thing is 6 feet. So you just add that, and so this would be 4 feet, regardless of whether or not I told you that here, right? I hope you understand that. So you can either jump straight to the top if you have enough information, or use your amplitude, right, to go one and then to the other. It did give you the amplitude technically from here, right? Diameter is 6, and radius is 3 feet, right? Which is also the amplitude. So lots of information here, more than what you need perhaps. So to get my midline, you have options. You add these divided by 2, or you simply go -2 plus the amplitude, which is 3, so that's a positive 1 foot midline. Okay, so everything is there. So I'm going to do question 2 here. Okay, so I'm going to come up with my 3 lines, -2, 1, 4. I start max, come back to it. You know the drill. Okay. You got to take this as your period, right? So it's telling you that the x-axis is going to be time, right? Not distance. Okay, so period is 5, therefore the x scale will be 5/4, which is 1.25 seconds. Okay, so I know that at time 0 I'm at 4, then it's 1.25, 1, then it's 2.5, a -2, then it's 3.75, 1, and 5, 4. Sorry, had a moment there. Okay, so those are your points. I'm going to go stat. So this is for question 2, stat, calc, sine reg. I didn't do it yet. So commercial break. It's doing other things. So 0, 1.25. And keep in mind, it's not always starting at time 0. If the question tells you otherwise, you could say, hey, after 10 seconds, you reach a max, right? Then it'll be 10, 4, and then you add your scale to that, right? So if you follow these steps, you should be in pretty good shape. 3.75, 5. See, let's see if I got it right here, because I feel like I'm rushing a bit. But that's why I have you to correct me. Is that what we're getting? The 3 sine, I'm pretty confident that that's it. That's your equation right there. We're good? I see nods. Because a couple things, you can add these two, right? Max plus min, that would be 2 divided by 2 is 1. Or you can go -2, knowing that the radius, because the height of the water is not your midline, right? That's just a reference point. That's what I want the ACs to be, the aha moment, right? Like, oh, okay, next time I'll know, right? And then sketch. I will look at your sketches, okay? I'll just look at it and mark it myself, because it's just gonna take too long. I know what it's supposed to look like, right? You have the points. I told you 1 revolution, right? If you did 2, hey, you're doing just fine. For how long is it above the surface of the water? Let's do that one together. Second trace 5. So I'm gonna just quickly, sorry, this is completely off from the previous question. Let's change my window. That's -3, and then we're going to 5, something like that. There it is. Above the surface, right? So you choose how you want to do this. I think if I go and find the caps there, it's easier, it's faster. So let me just increase my x max there. So I'm going to find the distance from here to here. it would make sense that it spends more time above than below, right? Given the fact that most of the, wait, so I'm going to just write that down. 3.4796 x2. You're going to get the same answer regardless of how you did it. And that is 6.5204. And so delta time is 6.5204 minus 3.4796. So that's 3.04 seconds. We're good? I will, yeah, 2 marks for that one. 1 mark for figuring out the 2 points, and then 1 mark for actually coming up with the time it's spent above the surface of the water. So don't put a total, anything like that. Just make sure your name and last name is on there, and the check marks and stuff like that. I'd appreciate that. And then pass it forward, please. I didn't do page 35, but it is in the key that I posted. That one is probably worth your time, page 35. But I'm going to go to 39 now, okay? That's a quick, we're just going to focus on the equation, no graphing, nothing else, just coming up with the equation. Because the rest, I'm fairly certain you know how to do. Page 39. And there's a bit of a problem there. And it's this. 3 revolutions per minute. So that kind of gives you the sense, oh yeah, I kind of figured that that's where I'm going to get the period from. But what's the problem? How many revolutions do we need? We're just interested in one cycle, not 3. So I'm going to figure out that the period is, watch how I'm going to go to seconds, 60 seconds for 3 revolutions. And I'm just going to go ahead and divide it, right? 60 divided by 3. That's 20 seconds for 1 revolution. This is how we want it, right? So if the question does anything other than just divide, just take the time and divide it by the number of revolutions that are mentioned, right? So therefore my x scale would be 20 divided by 4, which is 5 seconds. Boom, that's done. And perhaps it's a good idea to just do this right away. I will make a reference that my radius is 25 feet, which is the amplitude for us, right? In this case, it goes straight to radius, no diameter, right there. When time is equal to 3, the chair is at the lowest point on the wheel, which is 5 feet above the ground. So that time is not equal to 0 there. Okay, notice that. But it is actually giving you the exact starting point. The exact starting point. And so we're going to start at the lowest, come back to the lowest, and then just split everything in half. We know that we're 5 feet. You're going to be given enough to figure out the rest, but you just need to be careful. Okay, right? It does say we start at 5 feet. How am I going to get the rest of this? Well, you could say that the diameter is what? If the radius is 25, the diameter is 50. So you could go from here to there by adding 50. I'm just going to take the amplitude, right? Or my radius. I'm going to take this, and this is 30, and then take another amplitude, right? And this is 55. So you've got your y scale taken care of. There's the y scale. And here's my x scale, right? Y scale, X scale, inhale, exhale. And then so we know that at time 3, we're at the lowest height. No big deal. But you need to watch out, right? Time is not equal to 0. Just be careful. And then since you found your scale of 5 seconds, no big deal. Just keep adding. Keep adding 5, right? So those would be 1355, and then it's 1830, and then it's 23 5. And you should see that from start to end there should be, and we can tell that there's a period of 20 seconds, right? So boom. Let me just give you the answer, because this is the most complicated part, coming up with the points, right? I think I have it at least. I thought I worked it out. 25, that makes sense. 25 sine, and that's 0.3142 x minus 2.51. Sorry, plus 30. Just write that down so you have that example there. Since the bell is going to go, I'm going to give you the homework. And if we have time to squeeze in one more, I will do so. Okay, so page 50. And there's more, but I'm going to give you the 50 to 53. And here's a kicker. This is an old exam question on page 55. A lot of students struggled with that on the exam. Let's see if you can overcome it. I think you're ready to do just fine on that one. It's not that difficult in my opinion. It's just the wording maybe threw some students off, and the fact that time doesn't start at 0 threw students off. This is years ago, right? We're talking 4 or 5 years ago. But I will post the key to this. Practice, please. Practice at least 1 or 2. Try to figure it out. I would say if you're time constrained, then make sure you just find out the points and the equation, and then answering the rest or graphing, maybe leave that, right? Just come up with the equations. Have a great weekend, guys.